Until now, we've been looking at equations with just one variable, and because there's only one variable, we only need one equation. But if we have more than one variable, we need more than one equation, because if they were to give you an equation like x plus y equals 5, there's an infinite number of solutions to that equation. So we need an extra piece of information in order to be able to narrow it down. So there's a few different methods for solving simultaneous equations. The first one is the elimination method, and it's called that because you eliminate one of the variables. And you can do that by either adding or subtracting the two equations that you're given until one of the variables disappears. So if we're given this first one, x plus y is equal to 7 and 3x minus y is equal to 13, we call the first one equation 1 and the second one equation 2. It's a really good habit to do this, guys, and to then explain what steps you're doing. You don't want the examiners sitting there trying to figure out what has gone on in your head. So label them, equation 1, equation 2, and then what I'm going to do is I'm going to add equation 1 and equation 2. Now the reason I'm going to do that is because in equation 1 I have a plus y, and in equation 2 I have a minus y. So if I add them together, the y will be eliminated. So when I add them, you look at the left-hand side of your equations. X plus 3x is 4x, y minus y, well, that disappears. And on the right-hand side, 7 plus 13 is 20. Now I have one simple equation to solve. 4x equals 20, therefore x is equal to 5. So that's the first part of my solution, but I've only figured out one variable, the x. I also need to go back and find the y. So choose one of your equations and sub that back in. So I'm going to sub it back into the first equation just because that's the easiest one. 5 plus y is equal to 7, so y is obviously equal to 2. Good idea at this point to check. We just substituted that into our first equation, so we know it works for that one. Have a look at your second equation. 3x, so 3 5s are 15, minus 2 is 13. So I know that that has to be my correct solution. So we're going to have a look at another one. This one's not quite as straightforward. If you have a look at your two equations, your equation 1 and your equation 2, neither of them have the same a's or the same b's. So we're going to need to manipulate one of them in order to make these something that we can eliminate. So if you have a look at the first one, 5a plus 3b, and then the second one, 3a minus b. So I've got a plus 3b and I've got a minus b. If I take the second equation and I multiply that by 3, then I'm going to get 9a minus 3b is equal to 42. Now I have a minus 3b, plus 3b, minus 3b. I'm going to be able to eliminate the b's. So I'm going to call this equation 3, just to try and keep things really clear. And then what I'm going to do is add equation 1 to equation 3. So again, working on the left-hand side, 9a plus 5a, I get 14a, 3b minus 3b, so the b is eliminated, and 42 plus 14 leaves me with 56. So a has to be equal to 4. So then take your a and substitute that back into any of the equations. I'm going to substitute it into equation number 2 because then I've only got a b and it's just going to make things a little bit easier. So 3 times 4 minus b is equal to 14. So when I do that, b must be equal to minus 2. So again, just double check. So if I go back to equation 1, 5 times 4 is 20, plus 3 times negative 2, so minus 6, that gives me 14, and I know those equations are correct. So that's the elimination method. You eliminate one variable, so you have an equation with just one variable left that's easy to solve. So another method of solving these is called the substitution method, and this is where you take one equation and you substitute it into the other. So if you have a look at this example, x equals 3y plus 4 and 2x plus y is equal to 15. Well, we know what x is equal to, so it's very easy to substitute that first equation into the second equation. Trying to eliminate it would be a little bit more complicated because none of the x's and the y's line up. We've got x's on one side and y's on the other. You can do it, it's just taking an extra step. It's quite easy to just substitute number 1 into 2 though. So we tell them we are substituting equation 1 into equation 2. So when I do that, I end up with 2 outside of 3y plus 4 plus y is equal to 15. So now you need to expand out. 6y plus 8 plus y is equal to 15. So 7y plus 8 is equal to 15. So 7y is equal to 7 and y is equal to 1. So once you've got that, you need to substitute that into one of your equations. So I'm going to substitute back into my first equation, because then I'm going to have something that says x is equal to 3 times 1 plus 4, so x is equal to 7. So again, just double check. So 2 times 7 is 14, plus 1 equals 15. That has to be the solution to my equation. That's how you solve the equations in exercise 311. Good luck, and I'll see you in class.